Alright, so on this page we're going to evaluate some definite integrals. I do want to say anytime I use that u substitution, I am going to do it that first method where I just write t equals or x equals on the top for the limits. I am not going to change my limits of integration. I'm going to back substitute and plug in the original limits of integration. That's the technique I choose to use. Why do I bring that up? Because let's look at this first one. So it says the definite integral, the integral from 0 to 1 of e to the 4x dx. So again, if we pictured the graph of e to the 4x, which we could get on something like Desmos, what is the area beneath the curve of e to the 4x on the interval from x equals 0 to x equals 1? It would be some crazy looking shape, but we can find the area of a shape that's not a nice shape now by using our definite integral techniques. So again, if you remember from the previous section, if we have e to the 4x, anytime that's not an x, we're going to need to use u substitution, where you let u be whatever that exponent is. In this case, it's 4x. We take the derivative of u with respect to x, take the derivative with respect to x of both sides. I'd have a 4. I solve for dx by multiplying both sides by dx, dividing both sides by 4. I would have du over 4. I'm always going to substitute back in for u, and I'm always going to substitute back in for dx. I rewrite my integral, but here's where I need to be really careful with my limits of integration. This is the integral from x equals 0 to x equals 1 of e to the u du over 4. I can pull out that 1/4, so this would be 1/4 times the integral of x equals 0 to x equals 1 of e to the u du. Now, my limits of integration are in terms of x. That's perfectly fine because I'm treating this like an indefinite integral right now. My variable and my differential are both e to the u and du. Those match. So remember, the integral of e to the u is quite simply e to the u. We would have to say plus c, but since this is a definite integral, I don't. Remember, this is from x equals 0 to x equals 1. I cannot directly just plug in 1 and 0 because I need to back substitute for u. So this would be 1/4 times e to the 4x is what u is, and this is evaluated from 0 to 1. Notice I dropped the x equals now because it is in terms of x. So this would be 1/4 times, well, I can either do 1/4 times each one of these, or simply do 1/4 times and now plug in the numbers. This would be e to the 4 times 1 minus e to the 4 times 0. Again, I could have done 1/4 times each of them, or just do 1/4 and then do the parentheses. Well, what is e to the 4 times 1 is just e to the 4th. E to the 4 times 0 is e to the 0, which is simply 1. So I don't know what the textbook wants on this one. Most likely it wants the exact value. So this would be 1/4 times, well, it would be e to the 4th minus 1. Again, I could have distributed that 1/4. It wouldn't have mattered. I could have done, this is the exact answer. I also could have done a decimal approximation if it asked, but since it didn't ask for a decimal approximation, I'm just going to leave my answer in this form right here. Again, you could have distributed the 1/4. Let's go ahead and look at the next example. It says the integral from 2 to 5 of negative 1 over x dx. So we're finding, if you think about the graph of negative 1 over x, what's the area beneath the curve of that graph on the interval from 2 to 5? First thing I'm going to notice is we can pull out that negative. So I have the integral from 2 to 5 of 1 over x dx. Okay, and the negative out in front there. And if you remember this, this one doesn't require u substitution. This was the antiderivative, or the antiderivative of 1 over x was the natural log of the absolute value of x, right? So this would be the natural log of the absolute value of x evaluated from 2 to 5. So no u substitution. I don't need to worry about writing that x equals on my limits of integration. It's perfectly fine. So what is this? This would be negative, and then you would have the natural log of the absolute value of 5 minus the natural log of the absolute value of 2. I do want to notice here that 5 is positive and 2 is positive. Both of these numbers are positive, and if both those numbers are positive, if it's positive, you don't need the absolute value. So on my test, I'd accept it if you put the absolute value for both of those, but you don't need to. You could just use parentheses. So if you're getting it wrong on WebAssign or whatever homework software you're using, most likely it's because they do not want you to put the absolute values, because the simplified version would be no absolute values. Again here, this is an exact answer. I could have distributed that negative. It doesn't matter. I'm just going to put the natural log of 5 minus the natural log of 2 in parentheses, and then the negative on the outside. Again, I could have distributed that negative if I wanted to. Okay, let's take a look at the next example here. We have the integral from 1 to 4 of negative 3 times the square root of x dx. So again, if we were looking at the curve of negative 3x, we'd look at what's the area between that graph and the x-axis on the interval from 1 to 4. How do we find the area of that shape that it creates? Well, we do the definite integral. We can pull out that constant multiple, so this is going to be the integral from 1 to 4 of, and I'm going to go ahead and write it in exponential notation, so I'm going to say x to the 1/2 dx. This is no u substitution, it's a straight up integral for us using the power rule. So here I have negative 3 times, well, the integral of x to the 1/2, 1/2 plus 1 is x to the 3/2. Then we had divided by 3/2, but remember, anytime you're dividing by a fraction, it's the same thing as multiplying by the reciprocal. In other words, flip and multiply. So instead of dividing by 3/2, I'm going to actually multiply by 2/3. Usually I'd have to write my plus c here, but because it's a definite integral from 1 to 4, I don't. My 3's are going to simplify here, so here I have negative 2 x to the 3/2, evaluated from 1 to 4. I go ahead and, if you want to change that back to radical notation, that's perfectly fine. I'm going to be using my calculator anyway, so I don't care if you use radical notation or not. So this is going to be negative 2 times, now again, I could distribute the negative 2, but what I like to do to make it a little easier is just plug it into each part individually. So it'll be 4 to the 3/2 minus 1 to the 3/2. Okay. I don't know if you need a calculator to do that one. 4 to the 3/2 is the square root of 4, which is 2. 2 cubed is 8. So that first part is an 8 right there. 1, the square root of 1 is 1. Cubed is 1. So 8 minus 1 is 7. 7 times negative 2 is negative 14. So again, if you notice here, we do actually have, quote unquote, a negative area. But remember, this doesn't necessarily represent area. What this tells us is what's the area of the shape, but the number there tells us the direction. So this shape, because it has an area of negative 14, means it is below the x-axis. Okay, so let's look at this last example right here. This is always going to be an issue. When we do this one, if you look at the absolute value of x minus 2, I want you to look at the graph of the absolute value of x minus 2. If you looked at the graph of the absolute value of x minus 2 from the interval from 0 to 5, let's take a look at it. If I plugged in a 0, I'd have 0 minus 2, which is a negative 2, but then I need the absolute value of that, so that would be 0, 2. If I plugged in a 1, I'd have 1 minus 2, which is negative 1. The absolute value of that would be 1, so I'd have a 1, 1. If I plugged in a 2, I'd have 2 minus 2, which is 0. The absolute value of that is 0, so I'd have the point 2, 0. If I plug in a 3, 3 minus 2 is 1, so I'd be back up to a 1. It's 3, 1. If I plugged in a 4, 4 minus 2 is 2. The absolute value of 2 is 2, so I'm up at 4, 2. And if I plugged in a 5, 5 minus 2 is 3. Absolute value of 3 is 3, so I have this point 5, 3. So what do I want you guys to concentrate on? What do I want you to see? We're asking to find the area between this. Let me go between this function right here and the x-axis. So what I'm going to do is kind of shade this in two different colors. I have this first area right here, which is on the interval from 0 to 2 below the curve. And then I have this second area right here, which is from 2 to 5 using the other curve. Okay, so it seems to me like we could do two separate integrals here. I could look at the integral from 0 to 2 of the absolute value of x minus 2 with respect to x. And then I can add to it the integral from 2 to 3 of the absolute value of x minus 2 dx, okay? So here's the trick to this. How did I know to break it up at 2? Well, whatever's inside this integral, whatever's inside that absolute value, set it equal to 0. That's going to give you the value that you want to break your integral up at. That gives you the number that you want to break it up at, okay? So let's think about this now. If I look at just this first area, I'm going to look at this, just this red, this first interval, the area from 0 to 2. What is this line right here? Well, maybe it's actually easier to look at the second area over here from 2 to 5. What is this line right here? This line right here is x minus 2. I don't need to do the opposite of x minus 2 because that is the original function. All my values are positive. So the integral from 2 to, that should have been the integral from 2 to 5, not the integral from 2 to 3. The integral from 2 to 5 of this function is the exact same thing as integrating x minus 2 without the absolute values because all those values are positive. So the question then becomes, how about the area from 0 to 2? What do I need to integrate? Well, anytime I am less than 2, I always have to find the opposite of that number. In other words, I need to find the opposite of whatever x minus 2 was. We'll distribute that negative and you end up with negative x plus 2. So for the first part of this, I'm actually integrating the curve negative x plus 2, which is the opposite of the absolute value of x minus 2, the opposite of x minus 2. Because x minus 2 would have given us a negative number, the absolute value would have made us take the opposite of it. Okay, I know that's really difficult to understand. That's the math way of saying it. So what's the easy way for you to do this on the test? Because I know that's what you care about. The easy way for you to do it is set the inside of the absolute value equal to 0. That gives you the point in which you're going to break it up at. Okay, anytime what's inside that absolute value is going to be negative, just do the opposite of that function. Just do literally negative of that function. Anytime the inside of it's going to be positive, which in this case is 2 and above, you're going to do the original function, which is x minus 2. Okay. So now we have two separate examples here, two separate integrals that we're going to be doing. Let's integrate each one of these individually. The integral of negative x would be negative x squared over 2, and the integral of positive 2 would be plus 2x. Again, I need to evaluate this from 0 to 2. Plus, I would have the integral of x would be x squared over 2. The integral of negative 2 would be negative 2x, and I need to evaluate that integral from 2 to 5. I plug in the upper limit minus the lower limit, so this would be 2 squared negative 2 squared all over 2 plus 2 times 2. That's when I plug in 2. I'm going to subtract off when I plug in 0. I'm just going to quickly note, when I plug in 0, I'm going to get 0 because all those terms have x's in them, so I'm not going to show that work. Okay. Plus, now I need to plug in a 5, so that would be 5 squared over 2 minus 2 times 5. And then I'm going to subtract off when I plug in 2, so that would be 2 squared over 2 minus 2 times 2. I do each one of those pieces individually in your calculator to figure it out. I'm going to go ahead and write my answer as a decimal on this one, just because it is a nice decimal. But plug in each one of those into your calculator and see what you get. Looks like I'm getting a total of 6.5. Okay, so there, my integral, I'm getting a total of 6.5. All right, this problem to me is one of the more difficult ones. How do you integrate an absolute value? So what I want to do for you is I want to do another example of integrating an absolute value function. It's not in the notes, it's not in the book, but I want to do another example of this just to make sure you got it. So if it is on the test, you would be able to figure it out on the test. Okay? Let's try another example. I'm just going to add some more room here. Go down. So how would I set up something like the integral from, I don't know, let's just say negative 2 to 5 of the absolute value of x plus 3 dx. What would I do for something like this? Okay. Well, the first thing I do is I look at the inside of that function, and I look for when is it equal to 0. Okay, so I look at x plus 3 equal to 0. X plus 3 equal to 0. Subtract 3 from both sides would tell me x equals negative 3. So if I think about this function, if I'm looking at the domain, if I look at negative 3, if I plug in a negative 3, I would get 0. If I plug in any number other than any number bigger than negative 3, it's going to be positive. So look at my limits of integration. It's negative 2 to 5. Notice every single one of those would be positive values, and anytime it's positive, we use the original function. So integrating the absolute value of x plus 3 on the interval negative 2 to 5 is the exact same thing as integrating from negative 2 to 5 of just the original function, which is x plus 3 dx. In other words, in this example, I could have got the original function. So let's go back, though. What if I said the integral from negative 5 to 5 of the absolute value of x plus 3 dx? What would have I had to have done? Well, remember, we need to break it up at negative 3. Anywhere above negative 3, we're going to use the original function, which is x plus 3. Anywhere behind negative 3, anywhere below negative 3, I need to use the opposite of the function, negative x plus 3, which would be negative x minus 3 if we distribute the negative. So what would I have to do if this was the integral from negative 5 to 5? I'd have to break it up into two places. I'd have to do from negative 5 to negative 3 of the opposite function, which was negative x minus 3 dx. And then I'd have to do from negative 3 to 5, the remainder of the time, of, since that's where it's always positive, of the original function, which would just be x plus 3 dx. So this is how I would break it up. Always look at where the inside's equal to 0. Think about when is it going to be positive, when is it going to be negative. Anytime that value is going to be positive, you use the original function without the absolute values. Anytime it's going to be negative, you would have to use the opposite of the function.